Hello again, my name is Gavin Shaw. I work for Campbell Scientific here in Australia, and in this video I'm going to be showing you how to connect one of these AM1632 multiplexers to a CR1000. So the AM1632 is what we call an analog multiplexer. The idea is you can use one of these to connect up to 32 sensors to one channel on the data logger. So CR1000 has 8 differential channels without any extra modules. Using 8 of these, you could measure up to 8 times 32 sensors on the one logger. So if 8 channels isn't enough on your CR1000, you don't necessarily need to buy a new logger. You can get one of these multiplexers to increase the amount of analog sensors that you can measure on your CR1000. So this video is going to be about wiring it up. To wire this to a CR1000, you will need 6 wires. So 6 wires for the connection between this and your data logger. Now what I'm going to use in this video is one of these cables here. It's just a 6-core cable, nothing special about it, just copper wires. You don't need any special cabling. In general, the length between your CR1000 and your multiplexer is not going to be very long. So any sort of hookup wires you have are fine. This is a cable that we supply. Its part number is 9721, and there's a picture of it up in the corner here. So if you did want to order this cable with your multiplexer, it's a 9721 cable. Alright, well let's get to wiring this up. Okay, so the first thing that we're going to connect between our CR1000 and our AM1632 is power and ground. So the AM1632 runs off 12 volts and ground. So I'm going to wire a 12 volt terminal on the data logger to the 12 volt terminal on the AM1632. So I've already got my red wire from my cable in 12 volts on the logger. The next thing I'll do is I'll use this black wire here for my ground. I'm going to wire that into a G. So if you haven't used these terminals before, to open a terminal up to put a wire in, unscrew anti-clockwise, put your wire into the terminal, and then screw it up in a clockwise direction until you can't screw anymore. There we go. And then just give the wires a little tug just to make sure they're nice and firmly seated in those clasps. Okay, so red and black are now my power and ground, so we'll move up to the AM1632. And I'm going to be looking on this side here, these 4 terminals. There's a 12 volts and a ground terminal there. That's where my red and black wire are going to go. So I'm going to wire in red and black into 12 volts and ground. Alright, so our red and black wires are connected to 12 volts and ground. Next, we're going to connect up our CLK and our RES lines. So they stand for clock and reset. The data logger uses those to determine which channel is connected to this common channel here at what time. So we'll start with clock. It doesn't matter which wire color you choose. I'm going to choose white. I'm going to wire in, let's say, white and blue into clock and reset. There we go, so I've got white and blue into clock and reset. We'll move down to the CR1000. Right, so I have my power connected to my multiplexer. I also have my control signals, that's C1 and C2, going to clock and reset. The last bit of wiring that we need between the 2 devices are these 2 extra wires here. They are going to connect the actual sensor signals from the multiplexer to the data logger. So it's an analog multiplexer, it's for analog sensors, so they need to go into our analog inputs. Now again, it depends on your program. The example program that I'm going to be using is using 1H and 1L to measure the sensors. So I'm going to connect these 2 wires, green into 1H and yellow into 1L. Okay, those are the sensor signal wires connected. I'm going to move up to the multiplexer again. Find those same 2 wires, green and yellow, and now I'm going to wire these into the common terminal of the AM1632. This is the terminal that sequentially gets switched to 1, 2, 3, 4, 5 and so on all the way down to 32. And that terminal is COM odd H and COM odd L. So my green wire was in 1H on the data logger. So that wire is going to go into COM odd H, and my yellow wire was in 1L on the data logger. That's going to go into COM odd L. Alright, so I've got my 6 wires connected between my AM1632 and my CR1000, 4 control wires and 2 signal wires. Now the next thing I'm going to do is just make sure that this red dip switch here is in the down position, in the 2x32 mode. Now that means that I have 2 signal wires which are being switched into 32 separate locations on the multiplexer. Moving that switch up means that 4 signal wires, odd and even, will be switched into 16 locations on the multiplexer. Now last, I'm going to wire in my sensors. For this example, I'm using thermocouples. They're nice simple sensors. Here's a thermocouple here. It's got 2 wires, 2 signal wires. It measures a temperature and produces a voltage between these 2 wires to represent the temperature. So this is easy. I'm just going to wire 3 of these thermocouples into channels number 1, 2, and 3 on the multiplexer. Alright, I have 3 sensors connected now. We can go all the way up to 32 if we wanted to, but I'm going to stop there. Alright, so the idea is now that we'll write a program, and that program will use these control ports on the CR1000 to trigger the AM1632 to connect the first thermocouple to this channel, make a measurement, connect this thermocouple to the channel, make a measurement, connect the last, and so on all the way down the line. So the last thing to mention here is, for our particular example, I am using a 2-wire sensor on the multiplexer for up to 32 sensors. So I've made sure that my dip switch, this red switch here, is down in the 2x32 mode. If you have a 4-wire sensor, you could switch the dip switch up to 4x16 mode, and then you can have up to 16 4-wire sensors on your multiplexer. Okay, so that's how to wire up your multiplexer to your CR1000. In the next video, we're going to show you how to use Shortcut to create a program to measure your multiplexer. We're going to be using this thermocouple example, so it's nice and simple. So have a look for that on YouTube. Alright, I'll see you next time.